My name is Giovanelli. You can also just call me Gio for short. And today I'm excited to be presenting my work titled Exploring Bichronous Collaboration in Virtual Environments. And I want to talk briefly about the modern workforce, where we have skilled laborers with their own expertise distributed across multiple organization offices. And they also have the ability to have flexibility in how they approach work, whether it be that they work remote or from home fully, or they have sort of a hybrid work schedule where they commute to the office some days of the week and otherwise work from home. And we see this as a potential use case of extended reality technologies, where we can stay connected and collaborate using collaborative virtual environments, which are a virtual space where we can in real time embody ourselves and interact with our colleagues via avatars. And we can also interact with objects inside the environment. And those changes or interactions are preserved and then can be viewed using annotations, which are generic units of information such as text, images, animations, and so on. But there's been a problem with the research space for collaborative virtual environment designs in the fact that they've only investigated the dimensions of the time-space matrix, uh, originally inducted by Robert Johanson in 1989. And when he wrote the article about the time-space matrix, it was meant to be a generalization of collaborative groupware at the time, where we had the time and place or space dimensions with binary classifications of same and different. And the most notable or abbreviations are same time as synchronous and different times as asynchronous. And Johanson acknowledged that this particular matrix was simple and that it would evolve in a similar fashion alongside groupware technologies as time went on. And we can see that there has been an evolution of collaborative space. It's now a continuum where we have same place or co-located, different place or remote, and this sort of hybrid combination, which we can see in this image from Meta, where we have some co-located coworkers as well as some remote colleagues, whether they be represented by an avatar or just a two-dimensional Zoom screen. But time has not since been revisited or evolved. And I want us to think of an example that does already happen nowadays. For instance, we have Jane, and she is looking at a CAD model and inspecting it. And she's going through a recording by her colleague, John, that's talking through his own inspection notes of this CAD model. And she has a question. So she asks John to join her, and he does, and go through the recording with her in real time in order to field her questions as well as clarify information. What temporal state is this considered? Before, it was strictly asynchronous when we were looking at this recording, but now we have a real-time collaborator with us going through this recording information. It turns out that there has been an evolution of collaborative time. Bichronous collaboration, as it's been called. And this is referred to as the seamless integration of past archived information during a synchronous collaborative session. And what this opens up is the space for a collaborative time continuum. So Bichronous lies between asynchronous and synchronous extremes in this continuum. And the extent to which the Bichronous temporal state gravitates more towards synchronous or asynchronous depends on the quantity of annotation content inhabiting the scene during a live collaboration, compared to the quantity of live collaborators. And with that in mind, we articulated a research question. Specifically, compared to synchronous and asynchronous temporal states, how does the Bichronous temporal state impact the user experience of collaboration within a collaborative virtual environment? And so we approached this from an exploratory standpoint. We didn't have formal hypotheses that drove our research. What we wanted to do was create a scenario inside of a collaborative virtual environment where a participant would experience all temporal states. And we wanted to focus on specifically interview data that we collected after they went through our scenario, where we would use inductive thematic analysis to derive themes, and then we would support those themes with quantitative data collected by our system. But what did our system look like? Well, Our system had a use case of multi-scale object inspection, going back to that CAD drawing, but now inside of a virtual environment. And the annotation, rather than being a text or a sound, was a recorded avatar, which you can see in this image here is this pink translucent avatar. And the participant was able to interact with the playback system to watch this recorded avatar. They could rewind, fast forward by 5 seconds, or pause and play the recording. And the annotation was visible to all users inside of the collaborative virtual environment. And for our study scenario, the participant was instructed to act as a quality assurance agent, where they needed to review two specified annotations, and from the content of those annotations, find the defect name and cause inside of the CAD model and verbally report that to the investigator. And so now what does this look like? Well, we have a video here of a partial reenactment. It's been cut up a lot in order to save time, but I'll go ahead and play this now of one of our study trials.
The recording that you're going to look for is from Singapore. It's going to be SGTF 0930.
All right, I'm starting it now. All right, I'll get started with it.
Hey,
All right.
this is Finn, and it is October 23rd, 2024 at approximately 9:30 SGT. Ensure that no physical damage has occurred to the nozzle. Thank you.
So following these study trials, we had interviewed 20 participants in total, and we started our thematic analysis and derived our themes. And the themes that emerged were specifically interactional constraints, with subthemes of visual occlusion and social pressures, and then information processing, subthemes information recall and information understanding. And from our results, we learned that the Bichronous temporal state amplifies visual occlusion. This was reported by 55% of participants during the interview, with a direct quote stating, "I felt that I may collide with the entities or obstruct their view." And this was supported by our proxemics data that was measured by the system, where we can see that in the Bichronous state, compared to the standalone entities in the asynchronous and synchronous states, participants increase their distance to the entities, again, to avoid collision or obstruction of their view. Next, we learned that Bichronous amplifies social pressures, and this was reported by 65% of participants, with direct quote stating, "You feel pressured because someone is there waiting for you." And we found that this was supported by our action count data, specifically comparing between the asynchronous and Bichronous states, where we saw a significantly lower amount of actions performed by a user with the system in the Bichronous state compared to the asynchronous state. We also learned that Bichronous improves information recall, and this was reported by 75% of participants, with a direct quote stating, "To find the part that talked about specific information, the collaborator saves you more time." And this was supported by our behavioral interdependence data from a study questionnaire, where we see that when the live collaborator was present alongside the annotation, the participant could ask them to help locate information, leading to a significant decrease in behavioral interdependence in the Bichronous temporal state compared to the asynchronous temporal state. And then finally, Bichronous improves information understanding. This was reported by 85% of participants, with a direct quote stating, "You get the description of what you are looking at, and you can ask questions if you don't understand." We found this was supported by our attention allocation data. When the live collaborator was present alongside the annotation, the participant could direct clarifying questions towards them, resulting in reduced attention allocation to the annotation during the Bichronous temporal state, compared to the asynchronous temporal state. So in total, let's go back to our research question. Compared to synchronous and asynchronous temporal states, how does the Bichronous temporal state impact the user experience of collaboration within a collaborative virtual environment? And what we now know is that collaborating in the Bichronous temporal state is beneficial for processing information. We see that in themes of recalling information as well as comprehending or understanding information. However, it is detrimental to interaction behaviors as a result of visual occlusion, with the amount of extra entities, or social pressures. But with that, that's the end of my talk. Thank you very much for listening.